In this problem, you have to plan your journey with train across different days of the year, and you have to plan in such a way that you incur the minimum cost. And it has been asked a few times in Facebook, Amazon, and Google interviews. So first, let's understand the problem. So you will be given a day number, a list of days, and these days will be from 1 to 365. So it is a non-leap year, and each day is between 1 to 365, and you are planning within 1 year. And this list is strictly increasing. This is given. So no 2 days will be repeated. That is, you will just make one journey on a given day. And so the maximum size can be 365, since this list is strictly increasing and it can take a value from 1 to 365. So this list will also be of maximum 365 size. And then we have 3 types of passes that are available to us. Passes or tickets, whatever you like to call. So this is a daily pass, which is valid for 1 day. This costs 2 units. Next is weekly pass. This is daily, this is weekly, and this is monthly. That is valid for 30 days. So each month will be of 30 days and not like 31 or 30. This pass is valid for 30 days, this pass is valid for 7 days, and its cost is 7. And this is valid for 30 days. So you should plan your journey such a way that if you have multiple days which are in close proximity to each other, then you will think that maybe I should take a monthly pass. But if you see that one journey you make in January, next you make in February, or they are very wide, there are not too many clusters, then you would prefer smaller denominations. So for example, let's see this problem. Let's say you have to travel on these dates. What should be your strategy? So here you have to return just the cost, minimum cost, and not the actual strategy. So let's see. So a bare minimum upper bound you can get is to take a daily pass on each of these. So if you have, let's say here 2, 4, 6, so 6 days of travel, then straight away multiply that by 2. So you see that at least you have a upper bound of 12. That is, can we find a better solution? So if you take daily pass for each of these, it will cost 12. But can we group some of them together? So let's see. So for daily pass, the cost is 2 per day. For weekly pass, it's 7 days, 7 units. Let's say $7. So it's $1 per day. And for 30 days, it's 15. So it's $0.5 per day. But let's say you take monthly pass and you travel just 3 days, then it's not beneficial. Or if you travel just 5 days, then it's not beneficial. So let's say how we can solve this. So in this case, it will be not 12 but 11. And how is that? So let's say you take a weekly pass on day 1. So that is valid for 7 days, starting from that day itself. So you can travel till here using weekly pass, that is 7 days. And this is not within a week, so you cannot travel within same week. So you will take a daily pass to 2. So total will be 11. So how we can formally solve this? So in this case, let's say we have 1, 4, 6, 7, 8, 20. So we will try to build the solution bottom up. So I am hinting towards dynamic programming, and I am a big fan of bottom up approach. So you will see in most of my dynamic programming solutions, I prefer the bottom up approach, and here also I will do the same. So how we can build the solution? Let's say you are just given 1 day. Then what will be the optimum? You would say that we will take a daily ticket, and that's perfectly valid in most practical scenarios. But let's say in some hypothetical scenario, this monthly pass costs less than weekly pass. So a safe bet would be that take the minimum of these 3 tickets. So whichever is the minimum, the solution for just this one would be that one. In this case, 2. Now let's build the solution. So we know the solution from here onwards. So from here onwards, it was 0. There is no travel required, so no ticket needs to be purchased. From here onwards, we need to purchase the minimum possible value is 2, minimum of these 3. Now let's keep increasing the solution. We have to reach here. So now from here onwards, what will be the minimum? So you are here and you have solved some values on the right, and we have the optimal solution for here onwards in this direction. Here onwards we know the actual optimal solution. We are solving for this one. So what we will do, either we will purchase a daily ticket, so this will be part of a daily travel, 1 day travel, or it will be a part of weekly travel. We can club it with some days on the right and then take a weekly ticket and use the optimal solution here onwards, or club it in a monthly ticket. So for this day we have to pick one of these. We have to take one of the tickets. Let's say we pick a daily ticket. So what will be the optimal one of the solution for this? We have not yet the optimal solution, but one of the possibilities is that we take a daily ticket. So I will denote C1, the cost of ticket 1 for 1 day, cost of ticket for 7 days, and cost of ticket for 30 days. These three values are this only, 2, 7 and 15. So if we take a daily ticket, it will cost us C1, and then total cost would be, so we are just concerned about this part here onwards. Left side we have not solved. So we took a daily ticket, so it costed us C1 plus here onwards we already know. So if this was day I, this is day I plus 1. So it will be optimal solution, let's call it DP I plus 1. So this is one of the possibilities. Now other possibility is that we purchased a weekly ticket on this. So what we will try to include all the days within 7 days from this. Let's say till here in this ticket itself. And we cannot include these days since these are more than 7 days from this current date. So we include this many dates. So the cost will be C7 plus DP. Let's say this date is D7. So D7 is more than DI, that is current date, plus 6. So we cannot include D7 and onwards, and this is strictly increasing. So we can include till here. So this part we already have solution. So DP D7. So this is another possibility. And the third possibility you can think is we take a monthly ticket C30. So it costed us this much, and we can include a few more days in this. Let's say till here. So till here we included in, this is within 30-day frame, and just after this we have D30. D30 is one of the values from 1 to 365. So we cannot include this D30 or onwards. So we already have solution for D30. So DP D30. So these are the three costs. We have to pick minimum. So pick minimum of these, and this will be our DPI. So now we have DPI. Similarly, we will move here I minus 1, and again repeat the same thing and go on until we reach 0, and finally we return DP 0. So I hope it's clear. So what is the time complexity of this approach? So let's say we have a few days. So this is number of days given in this list, and let's say this is n number of travels are there, n number of days. So what we are doing, we are starting from here and moving till left. So this we make n iterations, and for each what we are searching for this D7 and D30, two values. So what is the maximum time D30 can take? Each of these days are unique and strictly increasing, that is given to us. So there will not be any duplicates. So max that we need to go to the right is 30 times. So this day is also within 30 days, this day is also within 30 days. So if we have all the possible consecutive days, it will be 30. But if some days are missing, it will be less than 30. And for searching for D7, we will at max make 7 comparisons. So for each, we can at max make 37 comparisons for each of the n days. So it's 37n. So it's O of n time complexity. And space, we are storing the solution for each of these in the dp table. So this is also of size n plus 1, or we can have n also. We will have to add just another condition. So we are adding for this one also, one hypothetical place after all the days are finished, so that we can generalize it. So for I, we can use I plus 1 plus C1. So that's why we can have one additional value. So space is also O of n. Now let's write the code for this approach in all the three languages. It should be very simple if you understand this logic. So this is the total number of days. Or you can use std array also, since the size will not change. So we can initialize with some value, some large value, and then we can only improve on top of that. So one rough estimate would be that we have 365 and costs 0. So this would be one way. So we have taken everything. We have taken a daily ticket for each day. You can also have int max here or some very large value. And the last one, after every travel has been made, we store 0 to make our code more generic. We can also ignore this. For int I equal to n minus 1, I greater than equal to 0, minus minus I. So let's initialize it with some value, dp I plus 1. So we bought a, so first option is to buy a daily ticket. So this C1. So we bought a daily ticket on ith day, and for dp I plus 1, whatever is the solution. Similarly, we can buy a weekly ticket and cover all the days within 7 days, and after that, whatever was the optimal solution. So this is the optimal solution, and we are starting from here. So dp I plus 1 plus C1. C1 is costs 0. Or let me write it before this. So in this case, daily ticket was purchased, and then we have to determine D7 after ith day to the right. So we initialize it with this, and D30, it's also initialized to I. So D7 is within current day, that is I, or rather days I plus 7. So we keep doing D7 plus plus. And very similar, we would search for D30. And dpi, the optimal solution from ith to last day, would be min of the current dp, this one. Or we can even skip this part. We can write here only this, then costs d7 plus dp d7. So now it will look more even in this min comparison. So buy a daily ticket, then dpi plus 1, buy a weekly ticket, dp d7, and costs 0, sorry, its length is 3 only. So 0 denotes daily cost, 1 denotes weekly cost, 2 denotes 30-day cost. And let's see, we have to return dp 0. Okay, if we have more than 2, we will need to include it in this. So it works for this case. Let's submit. And the solution is accepted. And we are around here 56%. But if you try a few times, I'm sure you will get right here. You can get much better. So now we will do it in Java. I don't think any change is required apart from some minor changes. So this is everything is initialized to 0, so we will not need this one. And then and Java solution is also accepted, and it takes 1 millisecond. Finally, we will do it in Python 3. And the Python solution is also accepted. And here it performs bad. You can try debugging why it's so much difference.